Okay.
Thank you, ma'am.
So it is like this. W is equal to fz. W is equal to z square plus 1 to power 1 by 2. And W can also be write as z plus iota into z minus iota to whole power 1 by 2. So we know that we can write change in argument of W. We can write argument of W as, because दो कॉम्प्लेक्स नंबर्स हैं, उनके आर्गुमेंट में जो चेंज होता है प्रोडक्ट का, वो वी कैन राइट लाइक दिस. आर्गुमेंट ऑफ W will be 1 by 2 argument of z plus I. Argument of z plus I plus 1 by 2 argument of z minus iota. Okay. So ये हमने प्रूफ भी किया था जहां मल्टीप्लिकेशन z1 into z2 बताया था. Okay. So change according to this formula, we can say so that change in argument in W, change in argument in W must be equal to 1 by 2 change in argument of z plus iota plus 1 by 2 change in argument of z minus iota. Okay. For suppose that यहाँ पे हमारे पास z plus iota and z minus iota है. It means that if it is our complex plane, so uh, z is equal to I and z is equal to minus I. These are 2 points here. So suppose that we are choosing a circuit. Let C be a circuit enclosing the point this I, enclosing the point I. Suppose that enclosing this point I, and we are moving along this circle in counterclockwise direction, because counterclockwise direction को हम positive direction बोलते हैं. So let C be the circuit enclosing the point I, but not z is equal to minus iota. ये सर्किल इस तरह से लिया है. It is only enclosing this point I. Okay. So when we will go around this circle C, the point Z goes once in counterclockwise around this C. Then what will happen? Argument of this Z minus I, must be changed in 2 pi. जब एक राउंड हम लेंगे अराउंड दिस कर्व C, इस पॉइंट के अबाउट, तो आर्गुमेंट ऑफ दिस z माइनस I मस्ट बी चेंज इन 2 पाई. बट क्योंकि इसके अराउंड हमने कोई भी चेंज नहीं प्रोड्यूस किया है, तो यहाँ पर जो होगा चेंज जो होगा आर्गुमेंट पे वो नो चेंज शो करेगा. इट मीन्स दैट दिस विल कॉज चेंज इन argument of z minus I is 2 pi, but change in argument of z plus 2I will be 0. So finally change in argument of W will be, so change in argument W must be 1 by 2 change in j plus I, which is 0. 1 by 2 change in z minus I, it is 2 pi, so it will be pi. तो W में जो चेंज हुआ वो केवल पाई, और जब हम वापस उसी ब्रांच पर आने चाहते हैं तो चेंज कितना होना चाहिए, 2 पाई। कंप्लीट राउंड जब कंप्लीट करेगा तभी हम ओरिजिनल पोजीशन पे वापस आएंगे। तो बट it is only pi, it means that when we are moving around this point z is equal to I along in a small arbitrary circle about this point I, so W does not return to its original value, hence W does not return to its original value. It means that, और अगर कोई पॉइंट ऐसा है जिसके अराउंड अगर किसी आर्बिट्री सर्कल में हम मूव करते हैं और फंक्शन जो है वो अपने ओरिजिनल वैल्यू पर मूव नहीं करता है, ओरिजिनल वैल्यू पर रिटर्न नहीं करता है जो भी हम ब्रांच लेके चले थे, सो वी कैन से that point is branch point. It means that z is equal to I is branch point of this function, branch point of function z square plus 1 to power half. Okay. Similarly अब हम इसके लिए z minus I के लिए नहीं लिख रहे हैं, लेकिन you can also say when let C be a circle या C dash be a circle, या सर्किट जो भी लिखना है, सर्किल around z is equal to minus I, then after one complete round change in W 1 by 2, change in z plus I will be 2 pi, but change in about z is equal to I will be 0. So again W will not return to its original value. It means that z is equal to minus I is also branch point of the function. Okay, branch point पूछा था उसने और पूछा था branch line. So branch line इस केस में क्या ले लें हम, देखिए this was the point I and it was minus I. तो हम क्या करते हैं कि एक कंप्लीट सर्किल ना हो पाए, उसको क्रॉस ना कर पाए, तो हम एक कट लगाते थे। वो कट कैसा होता था, उस पॉइंट से होकर निकलता था। वो कट जो होता था, जो लाइन होती थी, that line emerges from the branch points. So here branch points are I and minus I. So here I am simply, एक सिंपल लाइन लेने के लिए हम क्या कर रहे हैं, एक ये कट लगा रहे हैं, ये कट लगा रहे हैं इस लाइन में जो हमारा I से ओरिजिनेट हो रहा है, और दूसरा कट हम यहां से लगा रहे हैं, ये लाइन। सो दीज टू लाइन जो है ये कंबाइनली विल बी कॉल्ड, अगर हम चाहते हैं कि इसको क्रॉस ना करे या हमारी वैल्यू एक सिंगल वैल्यूड फंक्शन की तरह बिहेव करे, सो वी हैव टू इंट्रोड्यूस अ ब्रांच लाइन हियर, एंड दिस ब्रांच लाइन विल बी इमर्जेंट फ्रॉम दिस ब्रांच पॉइंट्स। तो ब्रांच पॉइंट से ये इमर्ज करेगी लाइंस, तो ये दिस कंबाइंड लाइन, ये जो पोर्शन ऑफ द लाइन है कंबाइनली विल ट्रीट लाइक अ ब्रांच कट फॉर दिस फंक्शन। तो क्या होगा हमारा, दिस इज द y एक्सिस, तो y एक्सिस का the part of y axis will be branch line. So branch line here is ये इसे क्या बोलेंगे, y is, this line is y is less than or equal to -1. ये पोर्शन जो है वो है हमारा y is less than or equal to 1, and this portion is y is greater than or equal to 1. So इनको combined ले लेंगे, so union of these two value, and इसमें साथ में ये भी लिखना पड़ेगा क्योंकि y एक्सिस पर है, so we have to write here, we should write here this line when x is 0, ये लाइन लिया particularly and x is 0. It means that y एक्सिस में ये पोर्शन जो है combinedly will be branch line. तो हमने यहाँ पे इसको ब्रांच लाइन ले ली। और यही लाइन इसलिए लिया है, कोई और भी आप ले सकते थे, यहाँ ब्रांच कट ऐसे भी लगा सकते थे, बट सिंपल लाइन थी तो इसलिए हमने इसलिए, आप ऐसे ऐसे भी ब्रांच लाइन ले सकते हैं, बस वो क्या होगा इस आयोडा से इमर्ज करनी चाहिए थी, लेकिन हमें सिंपल लेना था इक्वेशन, तो हमने सिंपल इक्वेशन ये ले लिया. So this will behave like the branch line for this function. So this line constitute the branch line. Okay. और क्या पूछा था? Yes. Show that the complete circuit around these points produce no change in branches of the function. So complete circuit around these points. अगर ये एक सर्किट हम ले लें, मान लीजिए इसको लेते हैं C1 सर्किट. C1 circuit which is enclosing both the branch points, दोनों both branch points को enclose करते हैं. So when we will move along this C1 one times in counterclockwise direction, so what will be in change in the in value of W. Okay, so let C1 encloses both branch points Z is equal to plus minus iota. As Z moves counterclockwise around C, then change in argument of J plus iota will be 2 pi, and change in argument of Z minus iota will be also 2 pi. So finally, change in argument of W will be 1 by 2, change in Z plus I, which is 2 pi, 1 by 2 change in Z minus I, it is also 2 pi. So finally, change in this W is 2 pi. So because it is 2 pi, it means that when we will move around a circuit which is enclosing both the branch points, so branch will not change. जो भी branch हमारी W की होगी, it will return on its original value. So for this point, change of the branch, there will be no change in branch of FZ. Okay, so this was the example related to multi-valued function, where we have discussed about the branch point. Am I audible?
Yes, ma'am, now you're audible.
Okay. So now start with elementary function. So first of all, I will start with exponential function. Okay. Exponential function of a complex variable z, where z can be written as x plus iy, is defined like e to power z, which can also be written as x plus iy, e to power x into e to power iota y. So by using the Euler's formula in place of this e to power iota y, we can also write exponential cos x plus I times, sorry, it should be y, cos y iota sin y. So u will be exponential cos y and its imaginary part will be exponential x into sin y. And this can also be write as, this can also be write as mm, z plus 2 pi I. E to power z plus 2 pi I can be write as e to power 2 pi I, and e to power 2 pi I means cos 2 pi plus I sin 2 pi, and cos 2 pi is 1 and sin 2 pi is 0, so its value is 1. So it is again exponential z. So it is also a periodic function with the period 2 pi I. So exponential z is periodic with period 2 pi I. So 2 pi I is its fundamental period, but if we are writing 2n pi I, it is any period of this function where this n is an integer. This n is any integer. So 2n pi is also the period for exponential z, but 2 pi I is here fundamental period for it. Okay. And third is, we can say exponential of z is never equal to 0 for all z in finite complex plane. Why? Because we know that exponential x, mod exponential x is always greater than 0 for all x in real number set, because uh, if we are writing mod of this exponential z, it will be exponential x into exponential iy, and and this can also be write as, and you know that mod of exponential y, it will be cos y plus I sin y, its value is always 1. So it is exponential x which is equal to x, and this exponential x, we know that exponential x for all real value x is always greater than 0. So it is always greater than 0. It means that mod of exponential z is always greater than 0 for all z. This implies that exponential z is never equal to 0, because exponential z is a complex function, complex valued function, और complex value में अगर mod 0 होगा only when uh, you know that mod of z 0 always implies that z is 0. So it means that mod of exponential z is always greater than 0 for all z. It means that it implies that exponential of z is not equal to 0 for all z in this complex plane C. Okay. And अगर इसकी differentiability की बात करें तो function will be differentiable everywhere. This function will be differentiable because its real and imaginary parts is, its real part u is exponential cos y, and imaginary part is exponential x, sin y. And you know about these two functions, x and y are real variables. So exponential x is everywhere continuous, everywhere differentiable. That's why this function is always differentiable. This function is also continuous and differentiable. So their product is also a differentiable function. तो u हमारे पास क्या है, differentiable function है. In the same manner we can say that v is also differentiable function everywhere in the finite plane. तो finite plane पे ये हर जगह differentiable है. और आपको पता है कि अगर एक थ्योरम हमने पढ़ी थी, इफ रियल एंड इमेजिनरी पार्ट कॉम्प्लेक्स वैल्यूड फंक्शन के हर जगह डिफरेंशिएबल और कंटिन्यूअस है, तो फंक्शन भी फाइनाइट कॉम्प्लेक्स प्लेन पे एवरीवेयर डिफरेंशिएबल एंड कंटिन्यूअस होगा. तो फंक्शन हर जगह डिफरेंशिएबल हो तो दैट फंक्शन इज कॉल्ड एंटायर फंक्शन. सो exponential z is also an entire function and its derivative with respect to z is exponential z. This is defined for all z in finite complex plane C. Okay. Question has पे the equation exponential z is equal to w has infinitely many solution, has infinitely many solution, many solutions. Okay, infinitely many solution means we will get infinite number of values when we will solve this equation. We will get infinite values of this z for which this equation will be satisfied. Okay, we know that अभी हमने एक प्रॉपर्टी पढ़ी कि exponential z is not equal to 0 for every z. So we can say here this w is not equal to 0 for all z. If w is a non-zero complex number, so we can write it in the polar form. So we can represent it in the polar form because it is a non-zero complex number. So this w can also be write as r e theta type. So it must be like this, r e phi, where this r will be modulus of this function. So it is mod of this w. So we can write it mod of w, and this phi must be principal argument of this w. Capital A is denoting principal argument and small a argument. Okay. So this w can be written w e I phi. Okay. We know that this w is exponential z, where z can be write as x plus iy, and this w can be write as ei phi. So exponential x iota e to power iota y mod of w iota phi. So here comparing real and imaginary part of these two variables, because these two variables are equal, so its real and imaginary parts are also equal. So we can say from here exponential x must be equal to modulus of w, and this y, because this can also be write as exponential, यहाँ पे हम लिख सकते हैं इसको, इस फाई की जगह पे हम यहाँ पे ये भी लिख सकते हैं, is general value phi plus 2n pi. So exponential x is modulus of w, and this y must be equal to phi plus 2n pi. Phi plus 2n pi, and this n belongs to set of integer. So here we get here we get क्या था, exponential x is equal to, this can also be written x is equal to log of mod of w. So x is log of mod of w and y is 2n pi plus phi. Phi is argument of this w. So z is, and n belongs to set of integer. So z is x plus iy. So substituting this value of x and y here, log mod of w plus iota phi plus 2n pi, where n belongs to set of integer. So you can see here, यहाँ पे z की हमारे पास for corresponding to every n, this z will solution of exponential z is equal to w. This will be the solution of this equation. So for corresponding to different n, we will get the different solution. It means that this particular equation exponential z is equal to w has infinite number of solution. Okay. तो यहाँ पे एक्सपोनेंशियल जेड के लिए हमने बात कर ली. नेक्स्ट टाइम हम ट्रिग्नोमेट्रिकल फंक्शन और लॉगरिथमिक फंक्शन को भी डिस्कस कर लेंगे, क्योंकि कहीं ना कहीं हमें क्वेश्चंस में ये फंक्शंस मिलेंगे. तो जब तक इनकी प्रॉपर्टीज नहीं पता होंगी हमें कॉम्प्लेक्स प्लेन में, उन्हें यहाँ पे सॉल्व करना मुश्किल होगा. ओके.